Hello everyone, and welcome to your I might add, historical geology lecture. This is Dr. Hurt, and today we're going to be talking about the origins of humans, okay? So at least I can say the origin of our human bodies. So I start with this picture here of Loskeel, Somalia. This is a set of cave paintings from 11 to 15,000 years ago, so gives you a little idea about what our ancestors were doing at that time. Kind of getting into the story, our main story here is human evolution. So where and how our bodies transformed over time to be what they are now. So humans evolved from the primates. Primates are a group of mammals with, you might be, of course, looking at these, quite familiar with these animals. So these are all primates, and by the way, you're part of the primate lineage as well. So, you're an animal. Kingdom is animal. Your phylum is, of course, Chordata. Your class is Mammalia, and the order is primate. Okay. So those are your kingdom, your phylum, your class, your order. Okay. Now we're going to even get down into your family and your genus and species. Of course, now your genus, of course, is Homo, and your species is Sapiens. Right. So Sapiens means wise. Your family is, so your order primate, your family is hominid. Okay, we'll talk about all these things today. So here are some different primates you're probably familiar with. There are lemurs. They're actually the most ancient of the primates. There are tarsiers. And there are the capuchin monkeys. These are the old world, or actually, capuchin is a new world monkey. Baboon is an old world monkey. And the gorillas are what are called hominoids, or sometimes people call them great apes. So just kind of a little overview of what the primates consist of. Now, things that all primates have in common is they have grasping hands, they have stereoscopic vision. That means that they can look, by looking at something, they can judge exactly how far away it is, okay? And they also have less specialized teeth than most other mammals. And these are all traits that are well suited for life in the trees, what's called arboreal life. Okay. Now, of course, we're a little bit different, but most primates are well suited to arboreal life. So our closest relatives are actually, to primates, are actually the Scandentia, which include tree shrews and squirrels. So the closest relative you have that is not a primate is actually like a squirrel that'd be in your backyard. So something to think about. So we split off from Scandentia about 55 million years ago. So basically 10 million years after the KT mass extinction. So order primate is split into two suborders. So we have the prosimians and the anthropoids. Okay, so here's primates. We have a primate ancestor. Primates, again, split off about 55 million years ago. And we had, at this time, prosimians were lemurs and tarsiers. Okay, so that split occurred in about 40 million years ago. And then everything else, so all the New World monkeys, Old World monkeys, gibbons, so all the great apes and humans are all anthropoids. Okay, so prosimians are kind of interesting. Their name means before simians, so prosimians. Simian means ape, so the apes, the creatures that were before apes. Prosimians are the oldest primate lineage, and their fossil record goes back to the Paleocene, so 40 million years ago. And during the Eocene, prosimians were abundant, diversified, widespread in North America, Europe, and Asia. So they were very common, but now we only find prosimians in basically just a few places. So they have not been as because they're an older species, an older family. They're out-competed by newer primates, so that we don't find them everywhere nowadays. But by the Eocene, prosimians were abundant, very diversified, very successful lineage of arboreal creatures. So that's 47 million years ago. Here's a Adapide fossil, Prosimian Adapide fossil from Germany. So even in Germany, right, which we think of as a relatively cold place, we don't think of it as a place where you find monkeys or anything like that. We find prosimians. And that was, of course, the reason for that is because, you know, it was a harsher, or I'm sorry, not harsher, it was a humid, hotter, more jungle-like climate back then, right? So as North America and Europe and other places became cooler and drier, we start to see changes in the habitat that greatly reduce the success and range of the prosimians. So we're going from jungles to drier grasslands. And I talked a lot about that in the last lecture, right? So that's something you want to know for the test. You want to understand is that we're going from jungles, thick, humid jungles, to grasslands, okay? So as the climate changed, North America became cooler, drier, forests disappeared and were replaced by these open grasslands. So by the late Eocene, new lineages developed called the anthropoids. So anthropoids are different than the prosimians. So there you go, about 40 million years ago we see a split, and we see the advent of New World and Old World monkeys, okay? So these are the monkeys. So the New World monkeys are things like this, the howler monkeys, I think capuchin monkeys are New World. All these different things are different monkeys you see are New World. So they broke off. You have to remember that around this time, 40 million years ago, we totally had broken off, South America totally broken off from Africa. So we saw this divergence between the African Old World monkeys and the Central American New World monkeys. Okay, so by the Oligocene, they were geographically isolated as the South Atlantic Ocean was widening. Okay, so New World monkeys live in South and Central America. Old World monkeys live in Africa and Eurasia as well. So notice though that Madagascar, because Madagascar broke off before, became isolated before New World and Old World monkeys came and before they evolved. On Madagascar, we only have prosimians. So there are no monkeys on Madagascar. There's only prosimians, which you know now are it's famous for lemurs, right? So lemurs. The reason that lemurs are able to survive there is because they're not competing with the monkeys. Okay. You'll notice also tarsiers still exist here in the South Pacific Islands. So now right before the Miocene, so now we're getting out of the Paleogene into the Neogene, we start to get the Old World monkeys splitting off and giving rise to the hominids, okay? Or the hominoids, I'm sorry. Hominoids are different than hominids. So the Old World monkeys split. So we came from Old World monkeys. We're more closely related to Old World monkeys than we are to New World monkeys, okay? So hominoids split off from the Old World monkeys. And hominoids are basically what we would consider us and the great apes. Okay, so things like gibbons were the first. You can see that gibbons are the hominoids that are most, I can say, like most monkey-like. The next split were things like orangutans, and then gorillas and chimpanzees. And as you can see, as we move from gibbons, orangutans, gorillas, chimpanzees, we're getting more and more human-like. Okay, so the hominoids split off from earlier anthropoids about 34 million years ago. That gave rise to the hominids. That's a family that includes humans, okay? So the hominids are not the same as hominoids. Hominoids include all great apes. Hominids are, the only extant species of hominid right now is us, okay? That's it. There's no other hominids. That wasn't always true over Earth history. There were times in which there were many different species of hominids. But right now there's just one species of hominid, and that's Homo sapiens. So hominoids, not hominids, but hominoids split off from the anthropoids, the great apes, and they are a new special group. Now, some special things about them is that they have relatively, now compared to us, they have small brains, okay? Compared to anthropoids, they had large brains. But they don't have the same kind of brains as we do. They have, they were still quadrupeds, so they were still walking at least partially on four legs. Their hands are not properly open. Their backbone is still bent. These include some of the apes, right? So hominoid evolution. So the earliest hominoids appear about 34 million years ago. So one of these was Egyptopithecus, which was unearthed in Egypt. And this appears to be a common ancestor between monkeys and hominoids. Okay. Now, hominids are direct relatives. So hominids are a family that broke off from arboreal chimpanzees around 7 million years ago. Okay. Now, these are not like the great apes at all. Very, very different. This is a game changer now. So the first hominids are these guys here, Homo habilis. We have a lot of fossils of Homo habilis, so we can talk about these quite a bit. So hominids are different than hominoids. Okay, hominoids includes the great apes. Hominids are just, we're the only hominid around right now. So the earliest hominid fossils are found in Africa. Okay, and that's the only places we get these Australopithecus. And so the A you see here, right here, stands for Australopithecus. This other one, the P, I'll show you a picture of that, stands for Paranthropus. Well, it's too far. I'll get to it eventually, I guess. But it stands for Paranthropus. Okay, so we actually had two different genus. So the family is hominid. The genus is either Australopithecus or Paranthropus. So we'll show you those two different genera. But the earliest hominid fossils are found in Africa. Okay, so we have Australopithecus and Paranthropus. And during this time, the interior Africa was like a lot of things in the world. We're going from dense jungle to grasslands and savanna. Now, of course, there is still dense jungle in Africa, but it's more along the equator, like in the Congo. And much of Africa looks like this, right? It looks like savanna. So you get sparse trees and grasslands. Well, really what the hominids are is they are a response to this shifting ecosystem. Because, you know, primates, monkeys, apes, they don't live in this kind of environment, right? Gorillas, orangutans, chimpanzees, they live here. They live in the jungle, right? They live in these dense forested jungles swinging from trees, etc., etc. You know, they're arboreal. They can't survive in these kinds of settings. So that's what hominids are all about. Our family broke off from the other hominoids because we were adapting to these grasslands and these drier, cooler conditions. So chimpanzees are hominoids. They have to find a way to adapt to this new environment that doesn't include so many trees and so much, includes a lot more grasslands. So the first change to occur in this time was bipedalism. Because, you know, if you're not going to spend so much time in the trees swinging from tree to tree, you need to walk from area to area. It's going to be more efficient to be able to, to be bipedal instead of walking on all fours. Because, monkeys are kind of clumsy trying to run and walk on all fours over the grasslands. So bipedalism was the first thing to evolve. So without the forests and these vast stretches of grassland, hominids needed an efficient method of locomotion because climbing was just not as important. Now, there was another huge change that you can imagine here is that now that we're walking on two legs and we're walking around the grasslands, our hands don't have to be so designed and so well adapted for climbing. So instead of having hands that are made for climbing in the trees, our hands can do other things. Well, what can they do? They can make tools, right? They can become dexterous, have extremely acute, dexterous hand muscles and fine motor skills. And that's what's going to happen. That's what's going to evolve. We're going to get hands that are well designed for grasping, for dexterity, for doing fine motor skills, things like that, along with bipedalism. So the first hominid genus we ever find, the very first hominid we have found, and this is pretty interesting because this is fairly recent stuff. Like when I went to school, we talked about hominids some of the oldest ones we knew about were this Australopithecus cadaba, Australopithecus ramidus, which is, you might have heard of Lucy. You ever hear of Lucy? Maybe not, but Lucy was an early Australopithecus ramidus. But the earliest when I was in school, so this is like 12 years ago, we learned it was Australopithecus cadaba, but you can see that now new species have come up that are significantly older. Okay, so that pushes back the time of hominid evolution. So this earliest one that we know of is Sahelanthropus chadensis. It was found in Chad, okay, in Africa, right? And we only have a skull, a partial skull. And you might look at this and be like, how do we know all this stuff from just a skull? But, you can see this skull is groundbreaking. It's very, very different than a chimpanzee skull. So if I show you these side by side, you might look at this and be like, that looks like a monkey skull or a chimpanzee skull, and that looks like a chimpanzee. But look at the skulls compared to each other. This is a chimp. This is Sahelanthropus chadensis, 7 million years ago. So there are some huge differences here. They're obviously not the same, right? So you can see that the monkey, not the monkey, but the chimpanzee has this very jutted out jaw, right? It has this big set of canines, big set of specialized teeth for chomping and munching down on vegetation. And Chadensis doesn't have that. He has a really flat face. He has a nice big brow, but he has a very flat face, really, compared to a chimp. Also, another thing you should notice is look how much bigger this brain case is. And that's pretty big, right? Compare that to the chimp. Chimp's got a little brain, comparatively, right? This guy's got a much bigger brain case. Another thing, notice, do you see this crest on the top of his head here? That's called a sagittal crest. Now, a sagittal crest, if I could kind of draw here. What a sagittal crest does is jaw muscles. So you have these big jaw muscles that connect here. They go through this orbit, this fenestrae right here. They go through there and they attach to the sagittal crest. So it gives some leverage and a place of attachment for very large jaw muscles, okay? Chimps need that because they're eating like tree root, like big roots and vegetation and a lot of stuff like that. That requires a lot of jaw muscles. Chadensis wasn't like that, didn't have this sagittal crest up here. So this was maybe a creature that was eating maybe more meat. Maybe it was scavenging more meat and maybe did a little bit of hunting. Maybe it was, eating more fruits and nuts and things like that and not so much vegetation, okay? So it's very interesting, very, very different kinds of skull you can see. So this is obviously a hominid and not a hominoid like one of the great apes. So Sahelanthropus chadensis is our earliest one, 7 million years ago. Okay. Now, other early Australopithecines. Now, these are a little bit kind of up in the air. So these are other early hominids. Aurorin tugensis. Now, this is a little bit, like I said, up in the air because this was discovered 2001 Kenya. The fossils include a femur that seemed to show that Tugensis walked upright. So that's why we call it a different, we're going to say like this was a hominid. We don't really know what his face looked like. We don't know what his skull looked like because we don't have a skull. We just have femurs and we have little bits, bone fragments, and we have teeth. But going off of that, we can see that whatever this animal was, it was definitely a hominoid. Or I shouldn't say it wasn't a hominoid, but it was different than the great apes, okay? Because it clearly, by the shape of the femur, it clearly walked upright. So we group this Aurorin tugensis as one of the hominids, okay? Australopithecus, not Australopithecus, Ardipithecus cadaba is similar. It's just a few fragments of bone, but it's enough to distinguish it from other known hominids, okay? Now, the first really nice, complete skeleton, I can't even say complete, but partially complete skeleton that we get of a hominid doesn't come until about 4.4 million years. So we know that hominids were around for at least 7 million years, from Sahelanthropus chadensis. So we know that they're around 7 million years, but we don't really get a good complete skeleton till 4.4 million years ago. So it's it's frustrating, paleontology. And at this point, we would actually call this not paleontology anymore. We would call this physical or archaeology at this point, or maybe physical anthropology. It's frustrating because it's like, these things are around, but the fossils just weren't preserved. So it's like I always say in this class, we're looking at the past kind of dimly, reflections through a mirror, so we don't see everything clearly. But so we don't get the full story. Were there older hominids? Maybe there were, but we don't know. But anyway, 4.4 million years ago, we get Ardipithecus. Sorry, I called it Australopithecus. Ardipithecus ramidus. So Ardipithecus ramidus, we get a pretty complete skeleton. We get a much clearer picture of what this animal must have been like. So we see dexterous hands. Okay, so I'm going to show you some pictures comparing him to, or comparing her. I think this one was actually a female. Comparing her to the hands compared to a chimp. You'll see they're very different. They have much longer thumbs. It's much more important for, having those longer thumbs is much more important for if you're doing kind of fine work with your hands. You're working with your hands and not just climbing, okay? We also see the feet are very different. The feet are more human-like. They do not have grasping feet. They are ones that allow them to walk upright. Okay, so the feet are not as, they're still, I can say they're still you could see how they have like these kind of opposable toes on the feet, but they're not as well designed for grasping and climbing through the trees. So by 4.2 million years, then we start to get the Australopithecus genus. Okay, so Australopithecus these were very highly developed. They were bipedal. They were totally bipedal. They had increased brain sizes. They also, you'll notice we had several species living at the same time. And actually, at this time, look how many species there were of different hominids at this time. So it's kind of weird because nowadays, we're the only name in, we're the only name in the game, right? It's just Homo sapiens. But there was time in Earth history in which we had several different species of hominids coexisting, So some of the first Australopithecines, we see Australopithecus anamensis, Australopithecus afarensis, okay? So here's anamensis and africanus. And these were again Australopithecines, sorry, and they are direct ancestors to humans. Okay, so direct ancestors to the Homo genus. So Australopithecines were bipedal, so you can take a look at their feet. Very different than Ardipithecus, right? Look at Ardipithecus. Ardipithecus still had these grasping toes, but it was still was still well suited for bipedalism, walking with the feet, but Australopithecus is basically got a foot like you and me, right? It looks very similar. Notice the hands. So this is a chimpanzee hand, and notice the finger length compared to the thumb length, right? These fingers are much longer. That's better suited for climbing. Whereas look at a human hand and a Australopithecine hand. They're much more similar to each other than they are to the chimpanzee, okay? So you could just see it. It's very clear here. Australopithecus looks a lot more like a human than it does a chimp, right? So it's walking upright. It's got human-like feet. It's got human-like hands. It still maybe has much longer arms than we're used to, and it has shorter legs than we're used to. But they're definitely looking more like a human than a chimp at this point. So Australopithecus, mostly fed probably on seeds, nuts, fruits, tubers. maybe that hunted a little bit, easy to catch small animals. And they probably did a lot of scavenging of meat, meat spelled M-E-A-T, not M-E-E-T, sorry for that. But probably didn't do a lot of actual like big game hunting yet. So another kind of side genus I talked about earlier was Paranthropus. So Paranthropus coexisted with Australopithecines. So Paranthropus was also a hominid, but these creatures were better suited for, basically better suited for a vegetarian diet. And they were probably feeding on big, thick tubers, crushing vegetation, and it went extinct about a million years ago. So we don't have Paranthropus, obviously, anymore. So they have a much more developed sagittal crest than Australopithecines, which again suggests that they needed those bigger jaw muscles for crushing vegetation. So now moving away from the other hominids, we're going to get into, for the first time, the genus Homo. Okay, so we're going from the hominid family. We're going to move away from the Australopithecines, the Paranthropus, the Ardipithecus. We're going to leave them behind, and we're going to start to talk about the genus Homo. So there have been a few animals, well, including us, in the genus Homo. The first one was Homo habilis. So Homo habilis is the first member of the genus, an earliest member of genus Homo. So dates between 2.4 and 1.8 million years ago in the Pliocene. Okay, so this was, you can see, coming at an end right at about the Pleistocene. So right at about the Pleistocene, where we start getting ice ages, this little guy goes extinct. So Homo habilis means handyman, and it's the first time that we see tool working, sophisticated tools being built. So Homo habilis was totally bipedal, walked totally upright. The face is almost totally flat, you can see. Teeth are less specialized, and we also see a much increased brain capacity. And you can see this looks almost like a human skull. You can probably notice that the brow looks sort of large, and the teeth and jaws look sort of, they kind of are jutting out a little bit more than you might expect for a person. But Homo habilis was much closer to us than any of these previous creatures we've talked about. So Australopithecines were now faced with even colder, drier climates than ever before, and shrinking forests. So instead of, fruit and nuts and vegetables, vegetable matter being a main source of food, more and more you're getting these grasslands, and the only thing to eat are large game animals. So hunting became an important activity. In order to survive, we needed to hunt. And in order to hunt, we needed to have a larger, more intelligence. So the search for large game was one of the main things that drove the evolution of the Homo genus. And we're going to see that the Homo genus is well adapted for life on the savanna, life in grasslands, and also for large game meat hunting. Okay, so in order to be intelligent, you need a lot of calories. Might shock you to realize this is true. Your brain eats up about 20% of your daily caloric intake. So that means that all the things, think about your heart pumping, your digestive system, all the moving around you do, walking from place to place, jumping if you do exercise, etc., etc., etc. All that stuff, your brain by far is taking up a lot of those, probably more than any other organ in your body. It's just your brain just doing the information processing. So you're burning calories big time with that big brain. So it needs a lot of energy. And it also needs, by the way, a lot of fat. In fact, animal fats are one of the things that human brains really like. They're really good at feeding them. So big brains require a lot of meat, especially a lot of animal fat, to feed and develop properly. So it's this drive for meat that was increasing brain size, and in turn it was feeding the brain. So meat became a very big deal for early, it still is a big deal for Homo sapiens, and it was a big deal for all of the other Homo members of the Homo genus. So a huge difference between the Homo genus and the previous Australopithecines and Paranthropus genus genre was the use of tools. So Homo habilis was the first animal to extensively use and create relatively sophisticated tools. So this is like maybe a stone chopper built by Homo habilis. These are all little kind of choppers and tools made by Homo habilis that you can see at different settlements. And you can tell that obviously somebody was working on these things and trying to shape them into something that would be useful. Okay, so like I said, Homo habilis went extinct by the time we got to the Ice Ages, and just kind of like you might remember, we saw this evolutionary trend when we were talking about Cenozoic life, of things getting larger, and that's going to happen too with Homo habilis. I mean, you can see, like, look how much bigger we are than an Australopithecine. We're a much larger version of that hominid. Okay, you're going to see the same thing. So next member we have getting into the Ice Age was Homo erectus. Okay, so about 1.7 million years ago we get Homo erectus, and right at the beginning of the Ice Ages. And these guys were larger, much larger than Homo habilis. They had a very flat face. They still had these brow ridges, but they look kind of getting pretty close now to human-like look, right? Totally upright, totally bipedal, very large brains, not as large as humans, but very large brains. So this Homo erectus was also a avid tool maker and an avid large game hunter. So our ancestors, especially Homo erectus at this time, this guy was a hunter for sure. So our ancestors were chasing large game animals on the savannah. The genus Homo is, as you know, we're not that fast. Maybe we can break 20 miles an hour if we're lucky, but it's pretty hard chasing antelope and things like that are running 30 or 40 miles an hour, right? So we do have a very special advantage over large game besides our brains, and that is we are very good at long distance running. A lot of animals are not that good at long distance running, so we are very well suited for running long distances, especially under hot conditions. So we're very well adapted for running in the heat. So one of the reasons we're so good is that we have something called thermoregulation, a very powerful thermoregulation over our bodies. That's our lack of body hair. Okay, so the fact we don't have body hair, means it's easier to shed excess heat. And we also have very well developed sweat glands. So that gives us one of the most efficient cooling systems of all the animals. In fact, we can cool ourselves off better and faster than any animal or any other mammal. Okay, so we have very good cooling systems, and that allows us to run in the hot savanna for a long time without overheating. A lot of animals cannot do that. We also have very long legs. Might surprise you to know that we actually have the longest legs of any mammal compared to our body size. So we have these nice long legs made for running. We have the plantar arch, that you know how we have an arch in our foot that gives us a little bit of springiness when we're running. We also have the Achilles tendon right back here, gives us some elastic springiness in our run. And also, if you look at our skeleton compared to other mammals, you'll notice that we have like big joints. We have nice big joints, and those nice big joints spread the stress of running over a larger area. So it's well designed to absorb shock. So we are great, besides being really smart, we are great runners. We are not the fastest runner, but we can run for a long time. And it might surprise you to know that a lot of animals cannot do that. I actually did this before. I used to live in Africa, and I was a Peace Corps volunteer, and I just kind of wanted to try this out, and I actually chased a goat. I don't know. I was bored. There's not a lot to do in the village in Africa. But I chased a goat just to see if this really works. And it really does. I chased a goat for like an hour. And what would happen is the goat could always outrun me, but I'd always catch up to him because he would do these short bursts but I could keep running and keep running and keep running. And eventually I'd catch up to him. And so then he'd do another short burst and get away from me, and then I'd keep running and keep running and keep running, and I'd catch up to him. Well, eventually he got so tired he had to give up. He just basically like collapsed from heat exhaustion. And I still felt great. I could still do that for another couple hours probably. But he was totally wasted after about an hour. So that's basically how early humans and how early hominids were hunting. So things like Homo erectus, and even to this day is how you can still hunt. It's called endurance hunting or persistence hunting. So deer can outrun you for short distances, but after a while the deer gets overheated and very exhausted and tired, so they can't run for very long. We, on the other hand, are very efficient runners and very well thermoregulated runners, and we can go for a very long time. So we exhaust our prey, and then we can strike easily. So Homo erectus is also a very avid tool maker, so you can see his or her tools were very sophisticated compared to Homo habilis, right? Obviously making spear points and things like this. And we also find at Homo erectus sites, we also find a lot of wood ash. So that shows us that these creatures were controlling fire. They were making fires, and that conveys a big evolutionary advantage as well, because when you have fire, you can cook meat. It helps you to destroy parasites and harmful bacteria, and also allows you the meat can last longer when it's cooked, right? Raw meat goes bad very, very fast. So Homo erectus was able to use controlled fires, and that was a very big deal for evolutionarily speaking in terms of success of the species. So we find also that Homo erectus was the first hominid to leave Africa. Okay, so Homo erectus left Africa, went into all over Europe, right? Even into Britain, into Italy, all over, a lot of them in Spain, a lot of them in France, right? Into Arabia, India, even Korea, in the South Pacific. So we find Homo erectus everywhere. They were very successful species, and only went extinct actually about 100,000 years ago. So there were actually still, it's kind of crazy, but there were still Homo erectus around when there were actual humans, like you and me, actual Homo sapiens. So they were around living together for a time, but obviously Homo sapiens just totally outcompeted them. But Homo erectus, as of yet, has still been the most successful hominid species and most successful member of the Homo genus, because they were around for 2 million years. Pretty big deal. So very, very successful species. Next on our list after Homo erectus is Homo neanderthalensis, which is, people might know, the Neanderthal. So Neanderthals they evolved in cold weather areas, and they were basically well suited. They were, evolved from Homo erectus, but they were perfectly designed for cold weather. And that makes a lot of sense because they came around in the Ice Age about 400,000 years ago. Okay, so this was the Ice Age. It was the middle of the Ice Ages and the middle of the Pleistocene. And you could see where we wanted to have, it would be advantageous to have a cold weather version of Homo erectus. And that's kind of what Neanderthals were. So Neanderthals were a little bit shorter than modern day humans, but they were much broader and thicker. And I don't know, I feel like a lot of people still kind of look like this, but they were generally kind of broader, bigger, more robust, and better suited to the cold. So they were built for the cold. They had larger, heavier bodies. And by the way, it might interest you to know they also had larger brains. So Neanderthals actually had bigger brain cases than modern day humans. Okay, and you can just look at it, it's pretty obvious here. This is a Neanderthal skull. Look at that brain case. Okay, very, very big. And you'll notice that just in general, the skull is much more robust. I mean, look at the teeth, look at the jaw, look how much thicker the jaw is. These were kind of more robust, stronger, heavier creatures than modern day humans. So, but Neanderthals were really pretty interesting because they did a lot of things, unlike Homo erectus, they did a lot of things that were like uniquely human. So it was kind of like the first creature that you might look at them and be like, yeah, that's like one of us. That's a human like us. So, were they human? Would you consider them human? Maybe it's up for debate. But they probably had clothing. We don't know that for sure, but given where they live, given their range, I mean, look at this. We find these guys in northern Germany during the Pleistocene. I mean, this was like covered with ice, covered with snow year round. So, I mean, it seems like they would have had to have clothing. So they possibly had graves and maybe even funeral ceremonies. So I'll show you some of the evidence for that. There seems to be evidence that they were caring for the infirm and disabled members of their societies. They seem to have had a language. They also possibly had things like art, jewelry, music, medicine. There's some things that maybe look like maybe they were musical instruments. We're not sure. It's hard to interpret what these things are, but I can show you exactly what I'm talking about, and you can kind of decide for yourself. So Neanderthals, we've never actually found any Neanderthal clothing because, I mean, it's the kind of thing that is hard to preserve in fossil records. So it seems, though, that it would be impossible for them to survive the cold temperatures of the Pleistocene without some kind of clothing. So that's why we kind of assume they wore clothes, but we don't know for sure. One thing that we find that's pretty interesting is that we find the remains of Neanderthals that seemed like the body was prepared. It seemed like they're in a grave site with like large rocks kind of placed, like people were building a grave site around him. They were preparing. We also find a lot of what's kind of interesting is we even find there's a lot of pollen in these graves. You can actually look with the microscope. Pollen, by the way, is really tough and really hard to destroy. It's actually very useful archaeologically speaking. It's very easy to survive the long ages and all the weathering and everything. So pollen lasts a long time. We actually find a lot of pollen loaded into these grave sites, which makes you think, were they possibly loading these up with flowers in some kind of like a funeral ceremony? So it's really interesting because for the first time we ever see this ever in the animal kingdom or anywhere in nature, we start to see this capacity for maybe like abstract thought or symbolic meanings, where you actually see creatures that care about meaning of things, not just bare bones fight for survival. So it's very interesting, right? We find things like this. Now, it seems undoubtedly these were being used as beads or some kind of decorative item. We find also a lot of red ochre paint, so pigments, that seems to be stored up. It seemed like as if somebody was gathering these pigments for something. Was it art? Was it body paint, makeup? We don't know. We don't have any cave paintings like we do from like our ancestors, Homo sapiens, but we do find things that kind of suggest maybe they were doing some kind of art, maybe some kind of jewelry. Possible. Another thing that's pretty interesting is we find Neanderthals with pretty serious breaks in their bones. And some of these things, doctors have, looking at the bones, looking at the injuries, it seems clear that it could not have healed without a splint or without some kind of treatment, which suggests that, again, Neanderthals were practicing some kind of rudimentary form of medicine, which again, and no animal has ever done that before. We also see situations where we find very old Neanderthals. So we can look at the bone the layers of bone growth, we could see, get a pretty good idea of the age. We find like 80-something-year-old Neanderthals that were also obviously crippled or obviously infirm and needed to be cared for. So that's pretty interesting, right? So again, it's not like we never found things like this before in the animal kingdom. So it's a real new thing of having kind of human-like creatures, things that people that are caring for one another. They're doing art, they're maybe doing medicine, maybe they're doing some kind of funerals, things like that. So it's a real important advance towards humanity that we know and love now. So sometime about 40,000 years ago, Neanderthals seem to have gone extinct. There are a lot of different ideas about why that might have been. Could have been competition with Homo sapiens, although some people have also suggested that not just maybe competition with Homo sapiens, but Neanderthals might have just been assimilated in with Homo sapiens, that they might have been mating and producing offspring. It's not known, but it's possible. Also, climate change, of course, in the Pleistocene, was another contributing. Climate change is almost always a contributing factor to extinctions. And also, one hypothesis I encountered also is kind of interesting, is possibly whenever we find these Neanderthal sites, they're always very small, 10 to 30 individuals. And some scientists have, offered the hypothesis that possibly these small societies, there might have been a lot of inbreeding, and which can cause, of course, many problems in the gene pool. So it's not known. We don't know exactly what happened. It's just hypotheses. Could be some combination of these things or none of them. We don't know. But anyway, extinct they are. We don't have Neanderthals around anymore. So the last species on our list, very well, because you're one of them, is Homo sapiens, right? Which means wise man. The first Homo sapiens were around 160,000 years ago. So you can see this is thousands of years. Maybe the first real fossil we find of them is maybe around 160,000 years here. So earliest fossil of Homo sapiens right there. Possibly were Homo sapiens maybe around here. We don't really know. But Homo sapiens are taller, more slender than Neanderthal. We're better runners. We're not so adapted for cold weather. We're kind of, because we can build very sophisticated clothing. We don't need to have such, bodies kind of adapted for cold weather. So we're also more intelligent than Neanderthals, even though we have smaller brains. So brain size isn't everything. Okay, so elephants, for example, have larger brains than humans. However, brain size helps a lot. It actually matters more how much gray matter you have in your frontal lobe rather than just plain bulk size, because for example, a bear might have a big brain. Look at a bear brain is pretty close in size to a chimp, but the brain of a bear is maybe more devoted to areas of sensory development, areas that help them to process their smells, the olfactory input, coming in through their nose, things like that. Not so much for processing abstract information like we are. So brain size, bulk size isn't everything. Okay. Also, a little bit more about our earliest relatives. So earliest humans are from Ethiopia. They're from the Great Rift Valley. So we're kind of originating in northwest Africa, northeast Africa. So maybe 200,000 years ago, 160,000 years ago, we have humans coming out of Africa. They're in Arabia by 100,000 years, so they're in like the Holy Lands and the Arabian Peninsula by about 100,000 years. From there, they move into India. They move down through the South Pacific Islands into Australia 50,000 years ago. They move into Asia 25,000 years ago. They move into Europe 40,000 years ago. And they move all the way into the New World, right, into into North America and South America 15, maybe 12,000 years ago. Okay, kind of the most recent advances were some going into Greenland, right, about 4,500 years ago, into Madagascar 1,500 years ago, and into these, New Zealand only 1,500 years ago, right? So it really wasn't too long ago that it's kind of funny because it's like it wasn't even what it was 1,500 years ago, so it was 500 years after Christ that you had people finally arriving in New Zealand, so it's really not that long ago, right? So anyway, you can see that the expansion of humans all over the world is actually fairly, just was completed fairly not too long ago, really. So I already went through all this stuff. Humans crossed into, so the first people to come into America, into our country, of course, Native Americans, so they crossed over. Probably the first Native Americans arrived here around 12,000 years ago. So it is widely, by that time, 12,000 years ago, we still had megafauna, right? We still had all the Pleistocene megafauna. So there were still woolly mammoths, there were still mastodons, there were still short-faced, massive, terrifying short-faced bears, there were still saber-toothed tigers, all that stuff. So but humans really probably played a big role in wiping those guys out, along with climate change, because the last glacial period ended around 12,000 years ago, 14,000 years ago. So it's widely suspected that humans hunted much of the megafauna to extinction. And by the way, you know what? They could definitely hunt woolly mammoths. It was funny because I was watching this documentary one time, and this guy, paleontologist, or I guess he would be an archaeologist, is saying, no way could humans ever bring down a woolly mammoth. No way. They could never do it with their tools. And I thought that was so funny that he would think that, because people have hunted in Africa. They've hunted, elephants with rudimentary tools as well. And actually, when I was in Africa, in Malawi, I actually knew of how they would do that. And the way that they would do it, I just think it's kind of funny how they would hunt elephants. But a very ballsy guy with an axe, not a spear, he'd have an axe like this. He would come up, so you would have people, still goes on today in Africa, okay? People still hunt elephants like this. You'd have these people kind of distracting the elephant. And then this guy would come up behind the elephant with a big axe. And he would come up, and there's a certain tendon right here on the inside of the elephant's leg. And this guy knows just where it is and just what to do. And he hits that tendon, chops it in two pieces on the inside of the elephant's upper thigh, chops it in half with that big axe, and that totally disables the elephant. It cannot move. It's just crippled, and then they just kill it from there. So I think definitely, without a doubt, humans were totally capable of hunting woolly mammoth and hunting the largest of these megafauna without any problem, I think. So as you well know, humans created very sophisticated tools compared to their ancestors. I mean, you can just see how much this is just in a totally different category of what we have seen before. So very, very sophisticated tools compared to Homo erectus. And another big game changer that came with humans is agriculture and domestication of cattle, right? So with the advent of agriculture came around maybe 10,000 years ago. Big game changer, because for the first time you produce enough food to make a surplus, so you actually have more food than people can actually eat, right? One person can make more food than they can actually eat. So that means that you could have a class of people that were primarily devoted to producing food, and then you can have other classes of people that were doing other things. And so this means that for the first time we had leisure. So that was a big deal, because now we can, with leisure time, you don't have to spend all your time working on food. You can develop history, science, technology, art, religion, law, medicine, philosophy, architecture, music. All these things that are, we think of as uniquely human can now be done because we have agriculture. Okay, So here are some of the very sophisticated tools built by Homo sapiens. Pretty advanced compared to Homo erectus, right? Here's some of the interesting habitats that have been constructed by Homo sapiens. Again, pretty different than what we saw with Homo habilis and other early hominids, right? And here's some of the interesting, very intricately decorated areas that Homo sapiens inhabit. The evolutionary, I write here, the evolutionary advantage of such behavior has not been deciphered by science. So, I'm kind of being a little bit funny here, a little tongue-in-cheek humor here, but hopefully you can see that, there's something about humans that is not entirely clear to science. Homo sapiens are one of the most interesting animals that we know of. And, you can see it's kind of funny in a way, because pretending humans are just merely animals doesn't work, right? It's kind of a joke. So one of my favorite authors, G.K. Chesterton, put it this way: the more we really look at a man as an animal, the less he will look like one. So this is why I always kind of make this emphasis between, talking about the evolution of our bodies, because I think it's very clear we're more than just a body and we're more than just an animal. So the more we really look at a man as an animal, the less he really looks like one. It is the simple truth that man differs from animals in kind and not in degree. So it means that we're something different. We're a different kind of a creature than an animal. It's proof of it. The proof of that is here. It sounds like a truism to say that the most primitive man drew a picture of a monkey. But it sounds like a joke to say that the most intelligent monkey drew a picture of a man. Something of a division, a disproportion has appeared here. It is unique. Art is the signature of man. So, for the first time you have people, right, doing cave paintings very early on, right? 40,000 years ago, 50,000 years ago, you have people actually making really good art in their caves and in their habitats, right? So I'm just trying to point out that we can't really understand human beings totally in the eyes of science, right? So you don't get the full picture by just exploring these ideas and exploring what it means to be human only through the eyes of science. So I'm just saying that, you don't need to make a choice between looking at man in terms of his body and the evolution of his or her body through the eyes of science, and reject, ideas about the origins of man that come from philosophy and religion. I think that they're complementary and needed to take both into account in order to get a fuller picture of what human beings are. So I don't want you to, reject one in favor of the other. I think they're complementary. Science, religion, philosophy are complementary, and we need both to understand, get a full picture of what it means to be human. So that's the end of this lecture and the end of this class. So I hope you enjoyed the class, you learned something that you find valuable, and I'll leave you with this, got another G.K. Chesterton quote, another great quote. All science, even the divine science, is a sublime detective story. Only it is not set to detect why a man is alive, but the darker secret, why a man is dead, but the darker secret of why he is alive. So anyway, I'll leave you with that, and I hope you enjoyed the semester. I hope you enjoyed the class, and I hope you learned something you find valuable in your life. And I will talk to you again when I post the final review video. So until then, you have a good week.